Analytical geometry is simply us doing geometry on the Cartesian plane. And the Cartesian plane is a grid that we're well familiar with. It's created by two number lines crossing each other at 0. And the system that is created by doing this is one where we can describe the position of various points using two coordinates, namely your x-coordinate and your y-coordinate. The x-coordinate tells us how far we've moved from the origin, either right or left, and the y-coordinate tells us how far up or down we've moved from the origin. So using those two numbers, we're able to describe the position of a point anywhere on the plane. Right, and just to recap some important language, so I've just kind of flippantly referred to this important point over here. It's called the origin. It's the point where your x and y axes cross. It's got coordinates 0, 0. And like I said, we describe the position of any point on the grid relative to the origin. So how far away from the origin have I moved? That is going to tell me where my point is. And the Cartesian plane is divided into 4 quarters, each of which is called a quadrant. And this is your first quadrant, this is your second quadrant, third quadrant, and your fourth quadrant. So that's just some important language around the Cartesian plane. Just one thing that we didn't define very well, but the x and y axes are the two number lines that I spoke about that create the Cartesian plane, these two number lines that cross each other, where your x-axis is always the horizontal number line and your y-axis is your vertical number line. Cool. So let's get into analytical geometry. The 3 very basic measurements that we concern ourselves with, at least at a grade 10 level of analytical geometry, are distance, the midpoint of a line, and the gradient of a line. Right, and so we're going to look at how the 3 of them are measured on the Cartesian plane. So let's start with distance. So basically, given 2 points, how can I find the distance between those 2 points? Right, so for example, given points 5, 2, and 11, 2, what is the distance between them? So useful often to first plot the points that are in the question. So 5, 2, so x coordinate 5, y coordinate 2, and 11, 2 is over there. So the distance between them is the length of this line, right? So let's just see over here. Right, we're asking ourselves how long this line is, and that's easy enough to see because it's a horizontal line. It's perfectly horizontal. We can just count the blocks here. So there's 1, 2, 3, 4, 5, 6. So 6 units. That's how long this line is. So that's easy enough. Let's look at another example. Right, given points 3, 1 and 3, 5, what is the distance between them? So 3, 1 will be there, and 3, 5 will be over there. So the line segment joining them will be 4 units long, right? 5 minus 1 is 4. And again, it's simple enough to compute because this line is perfectly vertical. So the only component to the distance between them is a vertical one. But this could easily be very different. Given points 1 and 3 and 9 and 9, what is the distance between them? So again, let's plot 1 and 3 will be here, and 9 and 9 will be over here. So we're trying to find this distance over here. And all of a sudden, there's both a vertical component and a horizontal component to the distance between them. What I mean by that is the distance between these two is no longer just a horizontal component like we had at first, or just a vertical component like we had at first, but we're moving both horizontally and vertically to get from one point to the next. And so in order to find the length of this distance, that didn't make sense. In order to find the length of this line, or the distance between these 2 points, we make use of Pythagoras, right? So the horizontal distance, the horizontal component of the distance squared plus the vertical component of the distance squared is going to give me this line's length squared. So what we would say is, so the distance, this distance here squared is equal to the change in my x's, right? So from here to here, how much has my x changed? What is the horizontal component of my distance? Plus the change in my y coordinates squared. So from here to over here, right, what is that distance? What is that difference over here? Right, and just to highlight that that triangle means change. So change in x squared plus change in y squared is going to give me my distance squared. And so that's what we do here. So my distance squared is going to be the change in my x. So we started at 1, we ended at 9, right? So the difference is 9 minus 1. And just note that even if you said 1 minus 9, it wouldn't matter because ultimately it's getting squared. So either way, it's going to end up being some positive number. And then we add the change in my y squared. So we started at 3 and we ended at 9. The difference there is 9 minus 3, and we square that. And again, even if you'd said 3 minus 9, which is minus 6, and you square that, it'd still be 36. Right? And you could calculate these individually, good brain exercise, or you could just punch it into your calculator. You should get 100. So this would be 64 plus 36, which is 100. So we now know that d squared is equal to 100. And so in order to get d, we're going to square root 100, and that would be 10. So we now know that the length of this line over here is 10. Let's look at another example. So given points minus 2 and 3 and 5 and minus 6, what is the distance between them? And so even though you could just use the formula straight away to figure out what the distance is, I think it's always a good idea to draw a rough sketch of what's going on. So minus 2 and 3 is going to be over here, and 5 and minus 6 will be down here. So we're trying to find the distance between these 2 points, right? And we know that there is a vertical component to their distance as well as a horizontal component. So my distance is going to be the change in my y squared plus the change in my x squared. And what is the change in my y? So we've gone from 3 down to minus 6. So 3 minus minus 6 is equal to 9, right? So we're going to square that. And my horizontal change is, okay, we've gone from minus 2 to 5. So 5 minus minus 2 is equal to 7. And it's important that you don't just say 5 minus 2. Otherwise, you'd be calculating the distance between here and here, right? 5 minus minus 2 means I'm going from 5 to 0 and then even more to get to minus 2. So that's why it's 7. Alright, so we'd have 9 squared plus 49, so 81 plus 7 squared, which is 49. That gives me 130. And the square root of 130 is roughly 11,4 units. If you're asked to leave it in third form, so that would be in this form, where you still have the radical sign, and you wouldn't have to work out a rounded answer. Right, so that's the long and the short of how you'd find the distance between 2 points on the Cartesian plane. And the formula, the general formula is to find the distance between 2 points, you are going to take the square root of the change in x squared plus the change in y squared, right? So basically those two sides of my right angle triangle added together, well, this squared plus this squared, and you take the square root of that to get this guy. So using Pythagoras. Or the formula that you'll see more commonly is this guy. So if we were to call the coordinates of this point x1 and y1, and the coordinates of this point x2 and y2, then you could give the distance as x2 minus x1, or like we discussed before, could be swapped around, x1 minus x2. Doesn't matter because the difference ends up being squared. So whether it's a negative difference or a positive difference, it gets squared and all is the same. So you find your change in x plus y2 minus y1, right? So you change in y squared, and you take the square root of that, and that will give you the distance between 2 points. So a very important formula to remember. Let's move on to the next important measure. Right, so midpoint. Given points 5, 2, and 11, 2, what is the midpoint between them? So let's plot the points. Right, so 5, 2 would be over there, and 11, 2 would go over there. And so you're looking for the midpoint of this line, right? Where is the middle point, right? And a bit intuitively, we kind of know that the midpoint will be over there at 8 and 2, right? What about if we're looking at a perfectly vertical line? All right, so given points 3, 1, and 3, 4, what's the midpoint between them? So first we plot those points, which you already have glimpsed 2 seconds ago, right? And the line connecting them, we're trying to find the point that's exactly midway between these two. And so we kind of have the sense that, well, what's the number that's right between 1 and 4? It would be 2.5. Right, so your midpoint would have the same x-coordinate, and the midpoint would have a y-coordinate of 2.5. You can kind of see that that's smack in between these 2 points. But now, what about in the case where we have a slanted line? Right, so given points 1, 3, 9, 9, what is the midpoint between them? So we plot our points as we did before, right? And we're looking for the midpoint between these two. And so, the learnings that we take from the previous 2 examples is, if you're looking for the midpoint of a line, you're looking for, seeing as this line has both a horizontal and a vertical component, you need the middle of the horizontal component and the middle of the vertical component. So I'm just going to outline those. So my midpoint is going to lie in the middle of this horizontal component and in the middle of this vertical component. So this horizontal component is 8, right? And if I half that, I get 4. So my midpoint is going to have an x-coordinate of 5. And this vertical component here is 6 units. So halfway through that will be 3, meaning that my midpoint will have coordinates 5, right? Because that's halfway, and 6. Or another way that we could think about it, and this is a useful way to think about it, is that my midpoint is going to have an x-coordinate that is the average of my 2 points' x-coordinates, right? Because that'll be exactly halfway between these 2 guys in terms of the horizontal component of the line. And its y-coordinate is going to be the average of these 2 points' y-coordinates, right? So that we can find which number is right in between these two, between 3 and 9. You find the average. So let's have a go at using that logic to compute the midpoint of another 2 pair of points. Alright, so given points minus 2 and 3 and 8 and minus 6, what's the midpoint between them? So by our logic, the midpoint is going to have an x-coordinate that is right in between minus 2 and 8. So the average between these two. And it's going to have a y-coordinate that's right between 3 and minus 6. So the average between 3 and minus 6. So let's do those calculations. So this is what we anticipate our midpoint will be. Minus 2 plus 8 divided by 2. So that's getting the average between these two. It gives us 6 over 2. It gives us 3. And 3 plus minus 6, or the other way around, whatever, divided by 2, which is 3 minus 6 over 2, which is negative 3 over 2. Right, so that's what we think our midpoint is going to be. Let's have a look. If we plot our points and the line connecting them, and let's plot this midpoint, that looks just about right over there. So